So today we're going to be talking about triangles. So we're going to be going over, so this is going to be over a few days. So today is day 1, and we're going to be going over triangle basics. So the area, the types of triangles, and then right triangles like the Pythagorean theorem, and special right triangles.
All right, but first we're going to review the homework from last week before we go any further. Okay, so one of the problems that was commonly missed was this problem: find the volume to the nearest hundredths using 3.14 instead of pi. Okay, so first we need to remember what the volume of a sphere, what the equation for the volume of a sphere is. And so that would be 4/3 pi radius cubed. All right, and then we see here that that 7 centimeters, I think that should be the diameter of the circle, I mean the sphere. So then the radius would be 3.5. And then you plug that in for r and solve the equation. And also you should use 3.14 as pi, like it states right there.
Okay, so the next problem. Find the volume of to the nearest whole number using 3.14 instead of pi. So this is a cone, as we can see. So we need to find, we need to first remember what the formula is for this. So for a cone, remember it's like a pyramid. So you do 1/3 times the base of the base times the height, right? So we get 1/3, and then the area of the base is just pi r squared, right? Because it's a circle. So we do pi, and then we are given 8, and that is because it's pointing to the middle, it should probably be the radius, right? So we do pi times 8 squared, right? And then we multiply it by the height, which is 9. So we can cancel out the 3 with part of this 9, and then we get 8 squared times 3 times pi, and we get 64 times 3. So when you do that, you get 192 pi, because you have to multiply the pi out. Don't forget the pi. And then you can multiply it by 3.14 to get your answer. And remember, for the homework, you can use a calculator. So yeah.
All right, and the last problem we're going to cover, the height of the cylinder is 3 feet. So we can go ahead and draw that in right here. And then you should find the total volume. So basically here we should find the volume of the cylinder and then add on the volume of the cone. So what's the equation for the volume of the cylinder? That is pi r squared h. And then the radius of the cylinder is 1.4. So then that's 1.4 squared times pi, which is 3.14 in this problem, times height. And then you add that to the volume of the cone, which, like we just did in the previous problem, that is 1/3 times pi times r squared times height. And then the problem gives you all of these values. So the radius of the cylinder is also 1.4, and the height of the radius of the cone is also 1.4, and the height of the cone is 2.6. So you would plug all of those values into this equation to get your final answer, which we're not going to calculate out right now.
If anyone has any questions, feel free to ask them. And if not, we can move on.
I have a question.
Oh yeah, go ahead.
So basically what you did was like you chopped that into 2 different shapes.
Right. And that is because although we don't definitively know, usually the diagrams, when they're shown like this, you can easily just tell.
Okay, so what is a triangle? Well, the definition of a triangle is a shape that has exactly 3 sides and 3 angles. Something important to remember about a triangle is that the angles inside it always add up to 180 degrees, no matter what. Okay, any triangle, the angles would add up to 180 degrees. And if you don't know that, you should write it down. All right, so there are a few different categories of triangles which are useful when we're like describing them or like in a problem. So they're important to know. First, we have an equilateral triangle, which is where all sides and angles are congruent. So just as a quick quiz, type your answer in the chat. If all of the angles in that equilateral triangle are congruent, how many degrees does each angle have to be? Yeah, exactly. So there's 3 angles, they add up to 180 degrees. So each angle is 60 degrees. All right, then second, we have an isosceles triangle, which is where 2 of the sides and 2 of the angles are congruent. And then one of the sides is going to be different. And yeah. Then we have a scalene triangle, which is where there are no equal sides and no equal angles. All right, 3 more types of triangles. And remember, these are kind of separate from the first set we did. So like, for example, a triangle can be both acute and equilateral, right? These are a separate way of defining a triangle. So first we have acute triangles, which means that they only have acute angles. And an acute angle is an angle that's less than 90 degrees. Then we have a right angle. So as you can see, it's symbolized by those little lines in the corner. A right triangle has a right angle, which is an angle that is exactly 90 degrees. And then finally, we have an obtuse angle, which is greater than 90 degrees. So you can see Ishani is indicating the largest angle in that triangle is an obtuse angle. Does anyone have any questions?
Okay, so using the 2 terms, using 2 of the 6 terms we just learned, describe this triangle. So remember that the first terms had to do with the side lengths. So scalene, isosceles, and equilateral. And then the second set of terms had to do with the angles. So acute, obtuse, and right. So in the chat, put your answer. Okay, so I'm seeing a lot of right scalene, and good job, you all are correct. So a right triangle should have a 90-degree angle, and a 90-degree angle, as we talked about in one of the previous classes, is symbolized by this like sort of square thing, this square-ish symbol, this 90-degree angle symbol. So that means that it's a right triangle. And then scalene means that it doesn't have any sides that are equal to one another. And we can see 3 is not equal to 4, 4 is not equal to 5, and 5 is not equal to 3. So therefore, this must be both scalene and right. Okay, so real versus impossible triangles. So say I draw a triangle with side lengths of 8, 12, and 22. Is that even possible? So the answer is actually no. So the two shorter sides in this case cannot connect with each other. So it can't form a closed diagram or a closed shape, meaning it can't be a triangle. So as you can see by this image drawn here, this 8 and this 12 do not connect, and they cannot connect no matter what. So this is not a triangle. So say I draw a triangle with side lengths of 8, 12, and 20. So is that even possible? So actually it isn't going to be a triangle because 8 and 12 sum to 20, meaning that it's just going to be 2 lines which are right next to each other. And that is not a triangle, that is just a line. So those two are impossible triangles. So there's a rule for making a real triangle, or a triangle that can actually be made in real life. And that's the sum of the two side lengths that are, the sum of the two smallest side lengths have to be bigger than the third side length, right? And otherwise, if this is not true, that means that that the lines won't be able to connect, or it'll form a line. So make sure to write down this, and it's the triangle inequality theorem. The name of this inequality. So we can see that if we have 8, 12, and 18 as our side lengths, it can form a real triangle, because 8 plus 12 is greater than 18. 20 is greater than 18, meaning these sides can meet, or they can connect. And 12 plus 18 is greater than 8. So that means that those sides can connect, and 8 and 18 are greater than 12, meaning those sides can connect. So, okay, there are 6 different triangles, and their side lengths are scattered on the screen. Sort them into real or impossible triangles and type your answer in the chat. Okay, so I will give you guys 3 minutes. So 3:16. By 3:16, you should have all your answers.
For number 4, it's the same thing. Number 4 and number 2 are the same, like,
Okay,
question.
sorry about that. Number 4 is supposed to be 7, 11, and 15. All right, I'll type it in the chat.
Okay, so it's 3:16, and I see some people, many people have gotten up till number 6. So you should be wrapping up at around this point. So we will go in order. So sides 3, 4, and 5. So we know that the small sides have the sum to be greater than the largest side. So 3 plus 4 is 7, and 7 is greater than 5. So therefore, this must be real. So real. Okay. Or actually, I'll just put a check. Okay. And then over here, we can see that 6 plus 9, right? They're the smallest side. So 6 plus 9 is 15. And 15 is greater than 14, meaning that this is also real. So check, right? And then we can see for number 3, we have sides of 28 and 31 as the smallest sides. 28 plus 31 is 59, and 59 is actually less than 64. So that means that this actually is not real because the sides cannot connect because they're less than the largest side. So this is incorrect. And then for number 4, we can see 7, 11, and 15 as the answer. So as the sides. So 7 plus 11, because those are the small sides, are 18, right? And 18 is greater than 15, meaning that this is real or this can be made. And then down here, number 5, we can see 20 plus 32, as those are the shortest sides, add up to 52. 52 is greater than 51, so this also is real groups. Okay. And then number 6 down here. So sides of 3, 8, and 12. So 3 plus 8 is 11, and 11 is actually less than 12. So that means that this triangle cannot be made. So therefore, it is not real. So therefore, the real triangles are, sorry. Okay. The real triangles are numbers 1, 2, 4, and 5. And then the impossible ones are numbers 3 and number 6. Does anyone have any questions? Okay. If not, then okay.
All right, finding the area of a triangle. So the formula for the area of a triangle is 1/2 times base times height. So in this triangle, you can see that 4 is the height of the triangle and 6 is the base. So go ahead and try to find the area of it and type your answer in the chat. Okay, everyone is saying 12, and you are all correct. So 1/2 times 4 times 6 equals 12. And that's how you would find the area of a triangle.
Okay. Okay, so problem 1. Find the area of this triangle. So we're given the base is 18 and the height is 6. So in the chat, type your answer.
Alex, you have your hand raised. Do you have a question?
It's not a question, but basically if it's a real triangle, you basically add the first 2 numbers and you'll have 3 numbers, and for example, it's like 3, 7, 15. So if you like add the first numbers, which is 3 and 7, and it's 10, and if it's less than the last number, then it's impossible.
Yeah, you should add like the smallest ones, the smallest sides, and they have to be, their sum has to be larger than the third side.
And real is the other way around, okay? Is that right? And the impossible triangle is the other way around, right?
Yeah,
Okay.
exactly.
Thank you.
Okay, so in the chat, I can see a lot of people have answered. So the answer is 54. So you do 18 times 6 divided by 2. Or you can do 18 times 1/2 times 6, which is equal to 9 times 6, which is just 54. Meaning our answer is 54 square units or just 54. Okay, problem number 2. Sasha has made a triangular frame out of wood. It has a base of 6 inches and a height of 2.5 inches. If she wants to cover the frame with fabric, how much will she need? So in the chat, type your answer. So remember, this is just another way of saying find the area of this triangle. So
I had a question.
yeah, go ahead.
So you're showing the area for a two-dimensional shape, right?
Right.
So three-dimensional, all you had to do is like multiply it by width,
By height.
by height. Okay, thank you.
Okay, so I'm seeing a lot of answers in the chat, and it is 7.5. So what you would do is you do 6 times 2.5 times 1/2. So you could get 6 divided by 2, which is 3, times just 2.5, and you would get 7.5 as your answer, right? I saw some people in the chat put inches. Make sure you put inches square if you want to put the units, because if you say 7.5 inches, that is not the right unit, and you could be counted as incorrect. So make sure if you do put the units, you put the right one.
Okay, on to a more challenging problem. 160 bushels of corn can be grown per acre. And there's Rosie's land up there in the picture. Her land is shaped like a right triangle. Given that an acre is 43,560 feet squared, how many bushels of corn does she grow? So this one involves a couple of steps, but try your best and type your answer in the chat when you're done. Okay, we have quite a few answers in the chat, so I'll go ahead and explain this problem. The correct answer is 1,600 bushels, so great job to everyone who got that correct. The first step here is to find the area of her land, which is that triangle in the picture. And the area of that is 660 times 1,320 times 1/2, which gets you 435,600 feet squared. And then coincidentally, that is equal to 10 acres of land. So that means that her land is 10 acres, and then she can grow 160 bushels of corn per acre. So 10 times 160 equals 1,600 bushels of corn.
Does anyone have any questions on that? Because a lot of you did not get the right answer.
I had a question.
Go ahead.
So how do you get the 43560?
So you're given it in the problem. So given an acre is 43560 feet squared. Usually when they ask you for conversions, they will give you the conversion. So in the problem. So.
But why did you decide to divide it? I thought you were supposed to multiply.
Because you are given that you have 435,600 feet squared, right? And you want to find out how many acres are there, right? So if you, okay, wait, let me type this. Okay, so if you, so you have units of feet times feet, right? So you want to eliminate that unit, right? So if we multiply by feet squared, we're gonna get feet to the power 4, right? So we get feet to the fourth power, and that wouldn't really make sense in our case, right? Because we're given a conversion of acre per feet squared, right? So if we multiply it by this 43560, this will be what our unit is. It would be feet to the power 4 divided by acre. However, if we divide, we get feet squared times acre over feet squared, right? And that basically just eliminates the feet squared. So you are left with acres. So you can't multiply because the units would not cancel out if you did.
Okay, I understand.
Okay. Okay, so special right triangles and the Pythagorean theorem. So the legs on the shorter sides of the right, the legs are the shorter sides of the right triangle. So you can see these are the legs, right? They're labeled here. And then the hypotenuse is the longest side, and it's always opposite the 90-degree angle. And then the altitude is the length from this vertex to a point on the hypotenuse that forms a 90-degree angle with the hypotenuse. And that's the altitude of the right triangle. So, okay. So Pythagorean theorem tells us how to find one side of the right triangle given the length of the other two. So we have a squared plus b squared equals c squared. So a is the shortest side, right? A and b are the shortest side lengths, and these are the legs. And when we square them and then sum them together, we get the hypotenuse squared. And there are proofs, however, we will not be getting into them really. Okay, so for example, we have this triangle. So it has two leg lengths, one with a length of 5 and one with the length of 12. So what we would do to solve for x, so let me demonstrate. Yes, so someone, Dheeraj in the chat typed 13, good job, that is correct. So what we would do is we'd do 5 squared plus 12 squared is equal to x squared, right? We're just setting up an equation with the given information, and that is that the hypotenuse squared is equal to the leg squared plus the other leg squared, right? So we get 25 plus 144, and we get 169, right, is equal to x squared. Now, if you've memorized your squares, you'll know that 169 is equal to 13 squared. And if you haven't memorized it, you can just do 13 squared right now, and you will see that 169 is 13 squared. So we get 13 squared is equal to x squared, right? And what that means is that x must be 13, right? Because if we find the square root of both sides, we get 13 is equal to x. So that means the x over here is equal to 13. So that would be how we would solve. Okay, so this is a GIF showing why it works. And it just shows that when you have the volume in two of the legs squared, right, squares of the legs, you will find a square with the same volume that has a leg length, that has a side length of the hypotenuse.
Okay, So let's do some practice problems. Problem 1, solve for x in the right triangle shown. Type your answer in the chat once you've finished. Okay, good job to the 2 people who got 24. 24 is the correct answer here. And so what you would do is solve for x using the Pythagorean theorem. And when you get the equation x squared plus 7 squared equals 25 squared. And so now you multiply those out. X squared plus 49 equals 625. Subtract 49 from both sides to get x squared equals 576. And then eventually you might have memorized that 24 squared is 576, but if not, you'll have to use a calculator. Or there's another way, which we'll go into very soon. So problem 2, Rob draws a diagonal line from one corner to the opposite corner on a square piece of paper. And if the sides of the square are 12 centimeters long, find the length of the line he drew to the nearest whole centimeter. Yeah, what's your question?
I thought you had to do 25 squared and 7 squared and add that up and see what you get for x.
Well, you should remember that like c squared always has to be the hypotenuse or the longest side. So you would put 25 squared on one side, and then you would do x squared plus 7 squared, which are the legs of the triangle, on the other side.
I thought this algorithm worked for no matter what side two sides you chose.
Oh yeah, you have to have like c equal to the hypotenuse.
Okay.
Good question. Okay, the correct answer for problem 2 is 17. So nice job. For these types of problems, it's often very helpful to draw a picture. So let's do that. Remember, it's a square piece of paper. So if you draw a diagonal line across it, you're going to have two legs that are the same length. And the length of those legs is 12. So then, so the equation you get when you use Pythagorean theorem is 12 squared plus 12 squared equals x squared. And then solve that to get 288 equals x squared, and x equals the square root of 288. Then we have to find the length of the line to the nearest whole centimeter. So that means that we have to evaluate the square root of 288 to be about 16.9, and then we round that to 17. So the answer is 17 centimeters. All right, does anyone have any questions before we move on?
I have a question.
Yeah, go ahead.
So is that 288 square root? The square root of 288?
Yeah.
Okay. Okay. And I don't understand how this works on a square.
Okay, so we're not doing it on a square. We have a square, and then the question says that we cut the square in half, basically. And then that gives us two triangles. So we're doing the Pythagorean theorem on just one of the triangles, like Ashani's drawing on the screen. And then because the question said like square paper, we know that the two legs or the two shorter sides of that triangle are 12. So that just helps us solve it. You can only
Okay,
do
so when you cut a square in half, you get triangle.
Yeah, exactly. And you can only do Pythagorean theorem on triangles, on right triangles. Okay, so let's move on to a concept that can help you solve these sorts of problems. And it's a Pythagorean triple. So those are just sets of three integers that fit the equation a squared plus b squared equals c squared. And a lot of the triangle problems you see will use these Pythagorean triples. So if you have them memorized, you don't even have to do all the math. You can just know it off the top of your head. So some examples are 3, 4, 5, 3 squared plus 4 squared equals 5 squared, and then 6, 8, 10, 5, 12, 13, 7, 24, 25, and then 8, 15, 17. All right. So it's often helpful to memorize those. And if you multiply all of the integers in a Pythagorean triple by the same number, it's still going to be a Pythagorean triple. So for example, 5, 12, 13 is a Pythagorean triple, and then that multiplied by 2, or 10, 24, 26, that's also a Pythagorean triple.
Okay, so 45, 45, 90-degree triangle. So a 45, 45, 90 triangle is an isosceles triangle, and it is also a right triangle. So the reason this is important is because we now have a relationship for using the Pythagorean theorem, we can find a relationship for the side length. So say that the leg length for this one is x, then that must mean that this is also x, because this is an isosceles triangle, so the legs must be the same length. And because it's a right triangle, we can use Pythagorean theorem. So you get x squared plus x squared is equal to the hypotenuse squared, right? And we can just say that it's question mark squared, right? So we can just find the square root. So first we have to simplify the left side. So we get 2x squared is equal to question mark squared. Question mark squared, right? So you find the square root of both sides, and you get square root 2 times squared x squared, which is just x. So we get x radical 2 is equal to question mark or hypotenuse, which is how we get this. So this relationship will always be true for an isosceles right triangle, since all isosceles right triangles are 45, 45, 90-degree triangles. And all 45, 45, 90-degree triangles will have this relationship. Does anyone have any questions on that? Okay. If not. Okay, so now using this relationship, find the length of side x. So again, you could use the, well, not again, but you can use the Pythagorean theorem. However, it's just easier to remember the relationships, because when you're in a math competition, time is crucial, and just remembering the relationships will save on time rather than having to
I just completely forgot all the relationships except x radical 2.
Oh, okay, I can redraw. Okay, so so we know that this is an isosceles right triangle because it's 45, 45, 90. So the legs must be the same. So you do x squared plus x squared, which is 2x squared, and you find the square root of that, and you'd get the hypotenuse, which means you have x squared 2 is the hypotenuse. So yeah. Also, because it's very easy to forget things in math, especially geometry, which this is part of, it would be really great if you guys would write this down, just so it can help you remember it later on, and you can just look back at your notes and be like, oh yeah, this is the relationship if you forget. And make sure to simplify it. So like if you have a radical that's like say square root of 32, you would simplify it to 4 square root 2. So similarly, simplify your answer for square roots.
Wait, so does this mean for this case it'd just be 5 times radical 2?
Yes, basically.
So 5 square root?
Yeah, 5 square root 2 is basically the answer. So this is an isosceles right triangle with and the length of the hypotenuse in a 45, 45, 90 degree triangle is the length of each leg of one of the legs multiplied by radical 2. So we get x is equal to 5 radical 2 as our answer. So yeah. So I already explained why this rule works earlier. However, this just shows that if we did the Pythagorean theorem, we'd get the same answer.
Okay, here's another special right triangle that you'll see a lot, and that's a 30, 60, 90 right triangle. So go ahead and draw this and write the relationship in your notes. You can see that there's a short leg opposite the 30-degree angle, which is x, and then that's half the length of the hypotenuse, which is 2x. And then finally, we have a long leg, which the length of that is x radical 3. And we'll explain why after you finish writing. All right, so something interesting is that a 30, 60, 90 right triangle is just an equilateral triangle that's cut in half. And so that makes sense. That explains why x, that short leg, is half the length of the hypotenuse, or the long leg. But now how did we get x radical 3? Well, of course, we use the Pythagorean theorem. And so that tells us that x squared plus, like we'll just say another variable, squared, equals 2x squared. And then we simplify that to 4x squared equals question mark squared plus x squared. Then that further simplifies to 3x squared equals question mark squared. And we do the square root of both sides. And then that gives us x radical 3 equals question mark squared. So then that's the length of the long leg of the 30, 60, 90 right triangle. All right, does anyone have any questions?
I'm confused on everything.
What were you guys talking about before before because I was in the bathroom. I didn't get what you guys were saying.
Okay, so 30, 60, 90 right triangles, they have a special relationship where, as you can see, basically look at one half of that triangle right there. The short leg is length x, and then that's half the length of the hypotenuse, which would be 2x. So for example, if that short leg, if x equals 3, then the hypotenuse is 6. And then finally, we have the long leg, which is the side opposite of the 60-degree angle. And the relationship with that one, that side is x radical 3. And we proved why it's x radical 3 using the Pythagorean theorem. And so going back to our example, if x equals 3, then the long leg would be 3 radical 3.
Okay, so make sure to write it down again.
Okay, so let's do some example problems. You can see a triangle on the left over there, and find x in that triangle. It is a 30, 60, 90 right triangle, as you can see by the labels. So what relationship would it have? Okay, I'm guessing you guys are a little bit confused, right? But I'll go ahead and explain how we would do this problem. So if you remember the 30, 60, 90-degree right triangle from the previous slide, the length of the hypotenuse was twice the length of the short leg. And so the short leg right here is 2. So then the hypotenuse is twice that, or so x would equal 4.
Okay, so I don't think a lot of you got the 30, 60, 90 triangle. So I'm just going to re-explain it, right? So say this is an equilateral triangle, right? So we know that it has angle measures of 60, 60, and 60, right? And if we just divide one of these 60s in half, then we'd get 30, right? So we'd have it right down the middle, the angle bisected, right? So we'd get 30. So that would leave us with two right triangles, right? Because we have 30 degrees here, right? And then we have 60 degrees here. So that means that 30 plus 60 subtracted from 180 is just 90, which is why we have a 90-degree angle here. So we can see that this must be half of this is half of the side length, as is this. And then this is the whole side length of that triangle, right? So let's just say that the half, right? So the half length of that whole side is x. So then this must be 2x, as Yolanda drew or wrote, right? So we now have a right triangle, right? And it has a leg length of x and a hypotenuse length of 2x, right? So now all we need to do is find this unknown side. And to do that, we can use the Pythagorean theorem, right? So we know that x squared plus question mark squared must be equal to that 2x squared, which is 4x squared, right? Because when you square 2 times x, you get 4x squared. So we can subtract x squared from both sides, and we get 3x squared is equal to question mark squared, right? And when you find the square root of both sides, you're gonna get question mark is equal to square root of 3 times square root of x squared, which is just equal to x radical 3, right? Is equal to question mark, right? So that means that our relationship for a 30, 60, 90 triangle must be x, 2x, and then x radical 3, right? As we have used the Pythagorean theorem and 60 and an equilateral triangle to prove this, right? So does anybody still have any questions? Because we know that it might have been a bit confusing. Okay, Aniket, you raised your hand. Go ahead.
So it can be any 30, 60, 90 triangle, and it's always that the shortest side is 2 times less than the second longest side, right?
Okay.
Like if the shortest side was 3, then the second shortest side would be 6, right?
No. So if the shortest side x, right, is 3, then you get this is equal to 3 times square root of 3. And you can't like eliminate that square root of 3 unless you multiply it by square root of 3 or divide it by square root of 3. So you get 3 square root of 3 for this, then you'd get 3 for this, as that's what we're given, and then you'd get 6 for this. However, what you're saying would work if you were trying to find the longest side. Yes, or yeah.
The longest side would be 6, but the second longest would not.
Right.
Got it. So then what would the second longest be?
It would be 3 radical 3.
Okay.
Yeah. Okay, does anyone else have any questions? Okay. If not, like your silence, I hope that means you guys actually understand it. And if you don't, please, please, please ask us questions so we know.
All right. Well, let's continue to problem 2 then. Problem 2 says that you should find the area of the triangle on the left. So same picture and find the area of that triangle. Remember, area is 1/2 base times height.
You mean like the salmon colored triangle?
Yeah.
Okay.
Okay, so let's give you guys all of you guys a hint. So first, let's just find all the side lengths of that triangle. We know from problem 1 that x equals 4, but that's not really relevant to this problem. We can still write it. And then from what Ishani was just explaining, we know that y is 2 radical 3. All right, And then you can also figure that out using the Pythagorean theorem. So now we know all the side lengths of the triangle. We know the base and we know the height. So find the area given that.
I forgot how to multiply radicals by whole.
Okay, that's all right. Well, we'll go ahead and explain this. So I'm sure you guys got the equation then. The equation is 1/2 times 2 times 2 radical 3 equals area. And then 1/2 times 2, that equals 1. So basically what you got is 1 times 2 radical 3. And 1 times 2 radical 3 just equals 2 radical 3. But just as a review of multiplying radicals, if you decide to do 2 times 2 radical 3 first, that equals 4 radical 3. And then you do that times 1/2, and then you get 2 radical 3 again. All right, does anyone have any questions here?
I have a question.
Yeah, go ahead.
Why would you do that type of radical? Then where did that extra 2 come out of? Would that be like part of the base?
The 2 is the base of that triangle. It's that shortest leg that you can see written on.
Yeah, but I saw you write 2 2s.
Okay, and then the other 2 comes from the length, the height of the triangle. The height of the triangle is 2 radical 3, because if you remember from before, like the rule for the 30, 60, 90 right triangle is that there's x, which is the shortest leg, hypotenuse is 2x, and then the other leg is x radical 3. So in this case, that leg would be 2 radical 3.
I thought Shani should okay, yeah, I understand. That makes much more sense.
Okay. Thanks for asking. Okay, so is anyone else confused on how to solve this? Because it's very important that we get this before we move on.
What's the hypotenuse?
The hypotenuse is like the longest side of a right triangle. So in that triangle, the hypotenuse is x, but it's not really.
So basically the hypotenuse is in every triangle, there's a slanted side. So the hypotenuse is always going to be that side.
I mean, it depends on how you look at it. Like if you rotated the triangle, the hypotenuse doesn't have to be slanted. But
okay,
yeah.
but so it's just the longest side on the triangle.
Also, just to clarify something, it isn't there in all triangles. It's only there in 90-degree triangles. We only call that longest side the hypotenuse when we have a 90-degree or right triangle, right?
So it's only there in right triangles. How do you find it?
It's just the side that's opposite the 90-degree angle. So that will always be the longest side.
Okay. I wasn't here for that, so I was just wondering.
Okay. Does anybody else have any questions? If not, okay, area of an equilateral triangle. So can you imagine how an equilateral triangle is just 2 30, 60, 90-degree triangles to put together? So we drew this earlier, right? We can see that it's 2 30, 60, 90-degree triangles put together. So we know that using 30, 60, 90-degree triangles, we can figure out the height, right? Because we know that the relationship must be, if this is x, then this is 2x, then this is radical 3x. So we have to multiply this side over here, this 1/2 s, by radical 3. And we get radical 3 over 2s, right? So that is the height. Now, to find the area of this, we must multiply that height by the base and divide it by 2. Well, we already have the base divided by 2 right here. So we can just multiply 1/2 s times radical 3s over 2. And we get radical 3s squared over 4, right? So that means that our answer is s squared radical 3 over 4, or s squared times radical 3 divided by 4. So that means that that is the area of our triangle, right? So you can see radical 3 over 4 s squared, right? And sometimes this can also be written as s, where s is the side length of this equilateral triangle divided by 2, that whole thing squared multiplied by radical 3. Because if you open this up, you'll get s squared over 4 times radical 3, which is just equal to what we have earlier, right? So we can write this as the side length divided by 2, that whole thing squared times radical 3. Or we can do the side squared multiplied by radical 3 divided by 4 and get the same answer. And make sure you don't do like s over 2 or s squared radical 3 over 2, because that is not correct, right? This is incorrect. And then you shouldn't do s over 4 squared radical 3, right? Because that is also incorrect. You're not going to get the same answer as this. So don't do those. Remember that if you have trouble remembering the area, then you can just you can just draw the triangle out, and you can find the height and the base of it. You can find the height of it given the side length, and then multiply by that by the base, and you will get the same answer, right? Although that might take some time. And does anyone have any questions on that? Okay, if not, we will move on. So we will be doing a Jamboard. Okay. Let it load.
All right, I put the link in the chat, so go ahead and join. All right, and we'll go through the problems one at a time. And what you should do is you should get a sticky note, write your answer in it. You can also write your name on the sticky note. And yeah. All right, so first question, what is the length of the hypotenuse of this triangle? Yeah, nice job. The answer is 8. So this is a 30, 60, 90 degree right triangle, and the length of the short leg is 4, and the length of the hypotenuse we know is double that, or 8. So good job.
Okay, so the question is asking for you to find x. So x over here is the angle measure of this. So make sure to put your answer on a sticky note. Okay, yes. So the answer is 15. So what you would do, is you do 21 plus 144, right? And you would get 165. And then you'd subtract that from 180 because as we said earlier, 180 degrees is the sum of the angles of a triangle. So 180 minus 165 is equal to 15. And we get 15. As some people have put. Okay, is this, wait, Yolanda.
Okay. Is this triangle acute, obtuse, or a right triangle? Use the laser pointer option at the bottom, and then just hover it over whichever option you think is correct. Yeah, or you can use a sticky note if you want. Okay, great job. This is an obtuse triangle. And why is that? It's because it has an angle that is larger than 90 degrees. So that 144-degree angle right there, that tells you that it is an obtuse triangle.
Okay, next question. Find the length of side x. So remember, these signs just mean congruent. So this means that that is equal to this side.
Whoever's making my sticky note bigger, please stop.
Okay, so a lot of people are putting 3 for their answer. That is actually not correct. So remember, if we do have two sides with length 3, because this is isosceles, right? Then you will get 3 and 3 and 6, right? And because 3 plus 3 is actually equal to 6, that means that it couldn't even be a triangle. So remember, when we have a 45, 45, 90-degree triangle, you have x, and then you have x radical 2, right? So we would get x radical 2 is equal to 6, right? Because x radical 2 and 6. So you would get x is equal to 6 over radical 2. However, you can't leave your radicals like this in the denominator, right? Because it would actually be considered unsimplified. So what you would have to do is you'd multiply both the numerator and denominator by radical 2, and you would get radical 2 over radical 2, which is 1 as what you're multiplying by. And then you would get 6 radical 2 over 2, right? And 6 radical 2 over 2, you would divide the 6 by that 2, and you get 3 radical 2 as your answer, which, yes, it is the square root of 18, which you say right here. However, that is not simplified. You would have to get it in this specific format.
Does my answer technically count?
Well, it would be like correct technically, but they would not count it as correct because they would expect you to give the exact value. So yes, it is correct, but it is not the answer.
Acceptable.
Yeah.
Okay, just wondering.
Okay, express the length of the longest leg using x. So the longest leg is just that side that doesn't have any label right there. you should express the length of that using x.
Whoever was just scribbling on on page 6, on page 5 on the thing, but please don't do that. 'Cause I'm trying to type my thing down.
Okay, just to clarify, the longest leg means like the longest side that isn't the hypotenuse. So 2x is the hypotenuse right here. And you're not looking for that, you're looking for the other one that's missing. Yeah, you're looking for that side length. All right, so does anyone remember what the relationship is in a 30, 60, 90 right triangle?
The relationship is the base is x, the hypotenuse is 2x, and the side adjacent to the hypotenuse is x to x rad 3. And I actually put that as my answer, but for some reason it didn't show.
Okay, I see it now. I see some people getting it. So good job. The answer here is x.
Also, whoever's just messing around on the slides, please stop. It's distracting.
Yeah. Please try to just keep it.
Answer the question and then shut up.
Okay, so the answer to this is x radical 3, and you can prove it using the Pythagorean theorem. Okay, so we'll continue on.
Okay, as Anushka said, please do not like scribble on the slides. And I think someone else said that before, like it's annoying and distracting. Okay, so find the length of the side labeled P. So P is over here, right? And remember, these are 90-degree angles. This requires you to use the Pythagorean theorem. So yeah.
Do we get to know what the angle relationship is?
You actually do not use angle relationships in this one. You just need to know that this is 90 degrees. And yeah, and so Pythagorean theorem. Whoever was like adding slides to the slideshow, please do not. That is annoying, it's distracting, and it's rude. So yeah. Okay, so find the length of the side labeled P. So you would use the Pythagorean theorem. So you'd find the leg squared, which is 6 squared, plus, and then the other leg squared, which is P squared, right, is equal to 10 squared, right? So we can, okay, let me just write this out, 10 squared, right? So what we can do is we have to first like open these up. So we get 36 plus P squared is equal to 100, right? And now we have to subtract 36 from both sides, and we get 64 is equal to P squared. So now you should know that 8 squared is equal to 64. So that means you just get P is equal to 8. So that is our answer. So good job to everyone on this slide who got it correct.
All right, so try not to work ahead, guys. But the next problem tells you to find the length of the side labeled Q. All right, and then if you've already solved it, go ahead and write out like how you got there. Write out all of your math on a sticky note.
Whoever just tried to copy my sticky note, please don't do that.
All right, so we have an explanation on here. That's perfect. So to find the length of Q, we would use the Pythagorean theorem. And so that tells us that 17 squared equals Q squared plus, and we already found P is equal to 8, so 8 squared. And then if you continue solving that, you get 289 minus 64 equals Q squared. So Q squared equals 225. And then take the square root of both sides. Q equals 15. All right. And you don't even have to do all that math if you remember Pythagorean triples. So here, these are Pythagorean triples, 6, 8, 10, and 8, 15, 17. So it's always good to just remember those.
Okay, find the area of this triangle. So remember, we did solve for the other parts of the triangle earlier, so you should already have the base and the height. However, you can solve for them again if you want. I'm going to give you guys 1 more minute just to give everyone time to do it. Okay, so we know that this is 8 because we solved for that in the first part. And we know that this is 15 because we solved for it in the second part. So to find the area, we find the base times the height divided by 2. So we do 15 plus 16, which is 21. And then we multiply that by the height, which is 8, times 1/2, right? So you get 21 times 4, right? Because 8 times 1/2 is 4. So you get 84. So good job to everybody who got it correct.
Okay, next problem. The length of the hypotenuse of a right triangle is 41 centimeters, and the length of one of the legs is 9 centimeters. How many square centimeters are in the area of the triangle? Okay, 180 is the correct answer here. So let's draw a picture of this triangle. We know that the hypotenuse is 41 centimeters, and then the length of one of the legs is 9 centimeters. So now we just have to find, so we know the base, now we have to find the height. So we'll say height is y. And then we use the Pythagorean theorem to find y. So 9 squared plus y squared equals 41 squared. Okay, and then you can see some more math on Dheeraj's sticky note. So if you solve that, you get that y equals 40. And then now we have the height and the base, and we can calculate the area. So area equals 1/2 times 40 times 9, which is 180 degrees. So good job to everyone who got that. And we'll just do one more problem probably before the end of this lesson.
Okay, so we said this earlier, but please do not work ahead, although you did that. So a line is drawn across the corner of this rectangle, forming a pentagon and a right triangle. Find the area of the pentagon. So this is a rectangle, and this is the triangle. Okay, so I'll go ahead and explain. So we know that this side length is 12 and this side length is 7. So that must mean that this is 5. And we know this is 25 and this is 13, so this must be 12, right? So what that means is that this is 12, 5, and 13, right? So that means that the area of this is equal to 5 times 12 divided by 2, which is 30. Whoever is like scribbling on the screen, please stop. Okay. So then we know that the area of the rectangle is 12 times 25, and that is 300, right? So we do 300, and then we subtract the 30 from it, right? And we get 270. So that means that 270 is the area of our pentagon. So yeah. Does anyone have any questions? Okay. If not, I think, yeah. So we don't have enough time for the Kahoot. So we will be letting you go. And the homework will be put in the Google Classroom. Have a good day. And if you have any questions, make sure to ask us, email us, put it in the Google Classroom.
Bye, everyone.
Bye.